Welcome students. Today we will cover electric field intensity due to infinite plane sheet of charge. Let us draw plane sheet first. Let this is a plane sheet and this is infinite in shape and uniformly positive charge distributions. Now what will I want to do? I think you have not forgotten. The first step is Gaussian surface. Let me write it again. Second step is electric field, ds and theta. Third step is flux formula, that is E dot ds, surface integral case. The next part is electric field, application of Gauss law, then find electric field. Same thing I will apply here, nothing more. I can draw here Gaussian surface sphere, I can take parallel pipe, I can take cylinder. Let us take cylinder. Very simple drawing. Now, for cylinder, three surfaces are there. So Gaussian surface is over. Now next task is, I need to draw electric field. Let it is situated at a distance of r. This side is also at a distance of r. I want to take point P. Let the point P is here. This is the small section area. So this is my ds vector and this is my point P. Since it is positive paper, both sides from positive due to symmetry directions will be there. So this is also electric field. Direction is normal to the paper. So angle between them is, let this is theta 1, 0 degree. Now if I will take surface for this case, let this is ds1. Different method you can take. Let this is ds2 vector. And here what happens? Perpendicular to the electric field. So what will happen? Theta 2 is 90 degree. Now the question is, similarly its another surface is here. Let us take its elementary surface is ds3. Obviously electric field is also in this direction. And theta 3 equal to 0 degree. So we got second step. Now the question is third step, flux. So flux is nothing but equal to, in this case it is a closed surface, that is phi 1 plus phi 2 plus phi 3. I can break it. Okay, let us write the formula first. That is nothing but E dot S. Now I can break this into three flux. Phi 1, let this is due to this reaction. Phi 2, let this is due to this surface. Okay, let this is due to cylindrical surface phi 2. and these two ends, let us write down phi 3. So if I write all these things properly, so I will get, now it is upon break into three surface, S1 E dot ds1 for surface S2 E dot ds2 for surface S3 E dot ds3. Now if I will break the dot product, this is E ds1 cos theta 1 is 0. This is due to surface 1. A dot B is AB cos theta, so E ds2, in this case theta 2 is 90 plus E ds3, in this case it is cos 0. Now cos 0 is 1 and cos 90 is 0, so this total is 0. Now in this case I will take E outside, integration of ds1. Similarly E outside, integration of ds2. Both have same area. Let that area is A. So if that area is A, so total integration will become A. So I got the answer 2EA. That is my flux. Now the next task is, so this third part is over. I'll go for applying Gauss law. So applying Gauss law, flux is nothing but total charge by epsilon naught. And since this is a surface case, okay, we'll discuss this later. Let us go from equation 1 and equation 2. I got 2EA equal to Q by epsilon naught, or E is equal to Q by 2 epsilon naught into A. Now Q by A. For surface charge distribution case, it is known as surface charge density. What will be its vector? Direction perpendicular. So this is in vector form. So from here it is clear, it doesn't depend on the distance r and size of paper. It depends on surface charge density. That means for the plane sheet, charge per unit area. It depends. To which constant? Sigma is also constant. Thank you. Welcome students. Now we will cover electric field intensity due to two thin infinite parallel sheets of charge. What is the meaning? I did not get it. Okay. Let us draw for the case 1, that is similar charge. So what is the situation? Let us draw it first. Let us take, you can draw it by pen and pencil. This is best scale you can use. And this is uniformly, let us charge by positive charges. Let it has sigma 1 charge density. It has also sigma 2 charge density. Charge by area, charge by area. Let charge is here Q1. Let initially charge is Q2. Then we will see similar, identical means what will happen. Okay. Let this is sheet A, or the first, and this is second sheet. So since it is positive charge and due to similar in nature, what will happen? Check it properly. Be careful. Positive means, just forget it. focus to here. Positive means electric field will be this direction, electric field will be this direction, this direction. That means what I am telling, away from this sheet 1. Is it okay? Now let us focus to only sheet 2. If I focus to only sheet 2, what will happen? Think it. This will be this direction, this will be this direction, this will be this direction. Forget this one. Electric field will be away from this sheet 2. Okay. This is inside the two plane sheets. This is for outside. This is for outside. Then we will think for two opposite charges happen, what will happen, we will see in different paper. For this case, let us mark it E1, 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 and for the sheet 2 case, let us mark it E2, E2, E2. What is my mistake? Vector. Now, let us go for first inside case. If I go for inside, the resultant electric field is E1 minus E2, or the vector will be plus, and if I take magnitude, since they are in opposite directions, that is E1 minus E2, so I will write, let us write down E1 minus E2, no need to confuse, in opposite directions, magnitude will be subtracted. Is it okay now? And what is E1? Just we covered. That is nothing but for a plane sheet, sigma by 2 epsilon naught. For E1 case, sigma 1 by 2 epsilon naught, sigma 2 by 2 epsilon naught. So 1 by 2 epsilon naught common, sigma 1 minus sigma 2. Now if I write, if sigma 1 is equal to sigma 2, then electric field inside is 0. This is clear. Or it will be 0. Let us go for outside. Either this side or this side. Both are same cases. They are in same direction. So resultant electric field is E1 plus E2. Or if I take its magnitude only, sigma 1 by 2 epsilon naught plus sigma 2 by 2 epsilon naught. 1 by 2 epsilon naught common, sigma 1 plus sigma 2. My question is, if similar identical charges are there, Q1 equal to Q2 or sigma 1 is equal to sigma 2, then this will be 2 sigma. So E will be equal to 2 sigma by 2 epsilon naught, or electric field is sigma by epsilon naught. This is for outside case. So for two similar charges, outside electric field is sigma by epsilon naught, inside electric field is 0. I think it is clear. Now question occurs, if two opposite charges are there. So this is the case 2 case. What is the case 2? So for opposite charge distribution case, roughly let me draw what you have to draw in exam. Pen and pencil, pencil and scale. Let in this case sigma 1 charge density, sigma 2 charge density. One is positively charged, another one is negatively charged. Obviously this is for inside the plates and this is for outside. This is for outside. But I told same thing we will follow. Let's go for this. The plane sheet 1, which is positively charged. So it will be away, isn't it? This case also away, this case also away. That means these directions, away from sheet 1. Since the second number sheet is negatively charged, what will happen? There will be towards. There will be towards because it is negatively charged. So let us mark it for E1 vector, E1 vector, E1 vector. This is for E2, E2, E2. Yes, whatever you are thinking, it is right. Inside they will be added, outside they will be subtracted. Let us follow the steps. If I'll go for inside, you observe same thing, net electric field will be added. So I will write inside electric field will be E1 plus E2 sigma 1 by 2 epsilon naught sigma 2 by 2 epsilon naught. So 1 by 2 epsilon naught times sigma 1 plus sigma 2. And if this is for inside general case, and if sigma 1 equal to sigma 2, then inside net will be equal to 2 sigma by 2 epsilon naught, or I will get sigma by epsilon naught. Obviously direction will be towards the second sheet. Now if I will think for outside, same thing, whatever you thought it is right, opposite directions in both cases. So I will write E out will be equal to E1 minus E2, that is sigma 1 minus sigma 2 by 2 epsilon naught. And if sigma 1 equal to sigma 2, it will be 0. So what is clear? Let us summarize. For the infinite plane sheet charge case, electric field is sigma by 2 epsilon naught. Two parallel similar charges case, outside sigma by epsilon naught, inside is 0. So outside is sigma by epsilon naught, inside is 0. In this case what happened? Inside sigma by epsilon naught, outside is 0. Thank you.